So when you read some of these gas law problems, either the ones in your textbook or the ones that I have put on Canvas or the ones that we're going to be doing shortly, sometimes you will see this abbreviation STP used. With regards to gas laws, STP stands for standard temperature and pressure. So when you see that an experiment is done at STP, that means that the temperature is 0 degrees Celsius or 273 Kelvin, and the pressure is 1 atmosphere. Okay? So that STP is that abbreviation is a standardized temperature and pressure that scientists have agreed upon when reporting certain thermodynamic quantities. It is often used in these gas law problems. And what's nice in particular about having a gas law problem that is done at STP, which is that if you have a problem that is done at STP, if you plug in those quantities in the ideal gas law, meaning you take it PV equals nRT and you put in 1 mole for N, and you put in 273 K for temperature and 1 atmosphere for pressure, you will see that when N is 1 mole, the volume of that gas is 22.4 liters. Why is that important or exciting? That means that 1 mole of any gas, it could be helium, it could be xenon, it could be nitrogen, as long as you have 1 mole of it and you are at STP, meaning temperature of 273 and pressure of 1 atmosphere, as long as you have those two qualifications, the volume of your gas is 22.4 liters. Now your mass is going to obviously be the same different. Masses will be different because your gases, depending upon their identity, have different numbers of protons, neutrons, and electrons, but the volume is the same as long as you have 1 mole of gas and you are at STP. So why is that exciting? That's exciting because if you are presented with a problem, and in the problem it says that the reaction is done at STP, you can automatically say, oh, if I have 1 mole of gas in this problem, then I know its volume is automatically 22.4 liters. So let's use this fact to help us solve this problem. Now I should say we could go ahead and solve this problem using just the ideal gas law, plugging in the appropriate values of standard temperature and pressure, but that would be a little more work. You'd get the same answer. Why not do less work instead of more? So in this problem, we say calculate the number of liters of gas, which in this case is going to be carbon dioxide. Calculate the liters of gas that form at STP when 0.879 moles of your reactant, calcium carbonate, undergoes this reaction. So I automatically know that with this reaction, if I have 1 mole of my gas, carbon dioxide, then my volume is going to be 22.4 liters. But I don't know how many moles of carbon dioxide gas I have. I do know how many moles of reactant I have, though, 0.879. I can use that along with coefficients of the balanced chemical equation to convert my moles of calcium carbonate to moles of carbon dioxide. And now I can use this statement about 1 mole of any gas at STP has a volume of 22.4 liters as a conversion factor like this. So my mole units cancel. I'm left with liters in the numerator, which is great because I'm looking for a volume. That is the answer I'm looking for, is to have liters. And so doing that multiplication should give you 19.7 liters. So when doing stoichiometry problems with gases, You may have to use the ideal gas law if you're not at standard temperature and pressure. But if you are at standard temperature and pressure, which will be told to you in the problem by saying it's at STP, if you are at STP, then I would recommend that you use this fact as a very quick conversion factor to use in solving these problems. There are sample problems like this on the Canvas worksheet, and that is the end of Chapter 11 on gases.